lot of mistakes there.
मैम
Okay. And जी,
जो मैम एक्सरसाइज 10.2 है उसमें पोलर ग्राफ दे रखा है और उससे इक्वेशन बनानी है, तो वो
हाँ,
कैसे बनाएंगे?
थोड़ा सा दिमाग लगेगा इन द सेंस कि अ, तुम देखो कि एक तो ओरिएंटेशन देखो, फिर तभी मैंने कहा था कि अगर कुछ शेप सिमिलर सी लग रही है जिसका कार्टेशियन में पता है इक्वेशन, उसको उस इक्वेशन को पोलर में चेंज करने की कोशिश करो। तभी मैंने स्टैंडर्ड कर्व्स बताए थे शुरू में, सर्कल कैसे हो सकता है, एलिप्स पैराबोला कैसा हो सकता है, या स्पाइरल कैसा होगा। तो उस तरह से ट्रांसफॉर्मेशन करना पड़ेगा। वैसे ऐसे क्वेश्चंस आते नहीं है एग्जाम में, दिस इज जस्ट फॉर योर प्रैक्टिस।
ओके मैम।
ओके, चलो, आई एम स्टार्टिंग नाउ। आई थिंक माय स्क्रीन इज विजिबल टू ऑल, है ना?
यस मैम।
या ओके। कल हम डिस्कस कर रहे थे parametric curves, right? And we had seen that your equation when x is some function of t and y is some another function of t, then such a curve is said to be a parametric curve. Okay. Now, the thing is that, of course, using this, we know how to find dy by dx that we had defined is actually nothing but dy by dt upon dx by dt, right? Now, for parametric curves, though I'm giving you the formula right away, but then we would be using this formula when we'll be doing the integration part. Okay, not now, but we'll be using it later on. So maybe in 10.1, there are certain problems where you will have to use this, or where we are supposed to find the arc length of a given curve. Okay, so for parameter, we have not discussed this in case of Cartesians. We have not discussed this even in the case of polar. So that we'll do when we do the integrations. But for parametric, since they have discussed it here, so I'll just give you the formula. The arc length is denoted by L and is actually given by the, say, supposing you have to, that means it's like, this is your curve, okay? And you have to find, say, supposing this equation gives me some curve like this, okay, some curve. And this curve is governed by this equation when x is a function of t, some function of t, y is some another function of t. And I am asked to find, see, a portion of this curve is nothing but an arc, right? Now, arc length in Cartesian forms, if you remember, you have all denoted it by something called as S, right? So in case you have parametric equation and you have to find the length of this curve, not when x or y varies between a and b, but when your t varies between a and b, or say t varies between t1 or t2. Okay, so with this variations in t, even x gets limited, and with this variations in t, even y is a limited portion, right? So that means we are just taking out a limited portion of this curve, and we are interested in finding the arc length of this curve, right? Now, logically, what do we do? What do you mean by arc length? It's like you have cut out a portion of this curve, extend it like, it's like your curve was designed by some rope or some thread. You take out a portion, whatever shape it had, then stretch it out. It becomes a straight line. Put it on a scale. That is your arc length, right? But it is not so simple to evaluate, right? So we have formulas to evaluate that. And for parametric curves, the arc length is given by the integral from a to b of under the root dx by dt whole square plus dy by dt whole square, and to be integrated with respect to t. That's why we have the limits a to b of t. Okay, so it's not x varying between a or b or y varying between a and b, it is t varying between a and b. So depending upon how the parameter is limited, according to that, we cut out the portion of the curve and then find the arc length. Okay, now, but then this formula will be used again when we do the integrations because it involves integrations. So that's what I was saying. Ki sometimes what happens is that like a question can be asked, ki find the arc length of a cycloid or find the arc length of a cardioid. So that means we need formulae to find the arc lengths, not just for parametric curves, but also for Cartesian as well as polar. So when we do the integration chapter, then we'll do it again. Okay. So this is only for 10 points, since in 10.1 there are certain questions that need to evaluate arc length. So this is the formula to be used. Okay. Now then again, like yesterday we were talking of some curve. I told you to imagine. Now, your imaginations were absolutely right. There was nothing wrong on that. Like I had asked you to imagine a tire of a bicycle moving, right? So we had said that it will be like when it moves, so it would look like, you know, superimposing circles, something like this. It's moving on a straight line like this, right? Something like this. So this is what you had all imagined, and somebody said you extend the spring and all. Yes, definitely. So it looks like this only. Now what we do is we just take a point, like it's like you tie a thread. Huh? I mean, you take a point here, you tie a thread somewhere here. Okay, this much distance. Take a point, put this as fixed. And as the cycle moves, imagine how this point will move. Okay, so that means I have fixed this point. Initially, my point P is at the origin. Now, as my tire moves, this point will move like this, come back here, and again it will move like this, and again it will move like this. Okay, so what happens is that we get a curve like this. Now, this is like you have fixed point, and it's like you have taken this distance OP same as the radius of that bicycle tire. Okay, and then you get curves like this. Such a curve is called as a cycloid. Okay, and this has a typical equation which is given by x equal to a theta minus a sine theta, and y is equal to a minus a cos theta. Okay, this curve, now it's a parametric curve dependent upon what? Theta. What is this theta? The angle which this radius vector is making at every stage, you know, as it is moving from here, 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 this P is changing, right? So the angle, if it's here, what is the angle? If it's here, what is the angle? If it's here, what is the angle? So this theta is that angle. Okay, so forget about that. You just treat it as a parametric curve. So I can write it as x equal to at minus a sine t also, and y is equal to a minus a cos t also. But then this represents a cycloid definitely. Now the thing is that why is this cycloid important? Because of its history, first of all. In fact, this is also, if you just read the book, this is also called as the apple of discord, because there has been a controversy on how this curve behaves. And also what you can do is just read this article like a story on page 689 of your Enton, and it's an interesting story. So you'll get to know कि scientists भी कैसे लड़ते थे, right? So, but then the thing is that we don't have just one cycloid. In the sense, see, you have two things, x and y, defined like this. Now, both have a negative sign, right? So this is going to give you a curve like this. This is a cycloid. Okay, this is how it is. It is going to behave, right? Now, from here to here is one arc of a cycloid, which basically is completed when theta varies from 0 to 2 pi. Okay, so this completes one arc, and so on and so forth. Now, the thing is that I can have, see, if I forget about the geometry behind, and of course not totally forget, geometry is important, but if I just see the algebra of these two equations, I say, why can't I have an equation like a theta minus a sine theta y is equal to a plus a cos theta. This should also give me a similar kind of a curve. Similarly, x equal to a theta plus a sine theta, and y is equal to a minus a cos theta. So this should also give me a similar curve. And why not positive signs with both? In the sense, x is equal to a theta plus a sine theta, and y is equal to a plus a cos theta. So all these four equations should behave in a similar manner, right? So that means they should give cycloids, but definitely some things will change, like if it's, so can I leave it now? Now how to trace it? To trace it, you just have to make a table, okay? Like we trace parametric curves. We give convenient values to theta. We get values of x and y, okay? And we join them for freehand curves, okay? Now this is a homework for you. You trace it, but take the variations of theta from 0 to 2 pi only, or from minus pi to pi. इन दोनों में ट्रेस करके देखो कैसा बन रहा है. बट ये चारों कर्व्स, आई गिव यू अ हिंट, यू विल गेट 4 साइक्लॉइड्स. कौन सा किसके साथ बैठेगा? एक तो यही आएगा, वो तो मैंने बता ही दिया. दैट विल गिव यू एन आइडिया. ऐसे स्टार्ट होगा. You will get one more like this, okay, something like this, right? Another one would be like this. This is also a cycloid, okay, and another one would be like this, right? Either se either. Okay, so just try and plot these 4 curves and then see which equation. It's like match the following, right? So this is 1, 2, 3, and 4, right? And I have given you 4 equations. So you have to match which equation matches with which shape, okay? So I'm leaving it as a homework for you. Try it on your own. So in parametric curves, only this curve is important, and the other one was that I gave you the other day, example number 6, x equal to t square, y equal to t cube. That is actually a, we call it as a semi-cubical parabola. It looks like a parabola, but it is not a parabola in complete sense, okay? Yeah, that's it. So for the time being, yes. But then as we go about, when we do the integration part, then I'll do more of parametric curves. Okay. So for now, 10.1 and 10.2 of your intern is over. Okay. We need to do 10.4 also, but then that is the sketching of conics that I'll do towards the end, right? Because it's not required right now. Since to start with integration, we needed the sketching part. That's why I've done these 2 topics first. Okay. Now, the next thing that we need to start with is, which I can today itself, we are now coming back to the simple functions that we left in between, where our equations are going to be Cartesian equations. Y as a function of x. Okay. Now, sometimes what happens is that it's easier to express your function explicitly in terms like this. Like you can straight away write y as some function of x. Like, for example, I can write y equal to x cubed plus 2 log x plus e to the power 5x. There's nothing wrong in it. I've simply expressed y as some function of x, right? But sometimes what happens is that the terms in your equation are such that you cannot separate out terms containing y and terms containing x. Okay, so that in a way, we say that we cannot explicitly express y as a function of x. Okay, such functions are called as implicit functions. Okay, now what we do is, like, why we are saying this is because whether we have an explicit function like this, or whether we have an implicit function where we cannot separate out terms like this, like I can have an equation like y equal to 3x cubed plus 5xy square minus e to the power xy. Or let's write it this, not like this. Better would be minus y equal to 0. Okay, now the kind of an equation we have is some function of x and y equated to 0, right? Now, this is also some function of y equated to 0, but it's such that I could express y as x, some function of x. Here it's not possible. Okay, so that's why we call such functions as implicit functions. But then when it comes to finding the derivatives, okay, we know we can differentiate even this function with respect to x. We can even differentiate this function with respect to x. What I mean to say here is whether I have an explicit expression or I have an implicit expression, I can find the derivatives. The only thing that I need to know here is that what kind of derivative am I evaluating, in the sense that if I say find dy by dx, now the moment we write dy by dx, it's understood that we are trying to study the changes in y when there is a change in x. So basically, it's like x is your independent variable, which is causing changes in y, which is your dependent variable. So that's why I'm getting, we have to differentiate y with respect to x. Okay, so that means we have to study how y behaves when there is a change in x, right? So that is why the only thing we must know is which is your independent variable and which is your dependent variable. So as far as this expression was concerned, not a big deal, because y was simply a function of x. We can directly find dy by dx, right? तो अब जैसे इसी को ही देखें, अब मैंने random बनाए थे, तो I would be needing the equations. So for the first function, if I say I will directly get dy by dx, what do I have to do? Simply differentiate the right hand side. So what will it be? 3x square plus 2 by x plus, what was that? E to the power, how much was it?
5x.
5x.
So I can write it as plus 5 e to the power x, 5x. है ना? यही आएगा ना इसका डेरिवेटिव. But supposing somebody says इसका भी निकालना है, I said okay, no point, no problem. इसका भी तो हम निकाल सकते हैं कि नहीं?
Yes, ma'am.
It's just that we have to understand that my y is the dependent variable. So that means I am differentiating with respect to x. So that means, like in the first term, if for the second, this kind of an equation, if I differentiate, I will not be evaluating dy by dx, but I would be differentiating this expression throughout with respect to x. And wherever there is a term containing y, I will have to add the differential of y with respect to x. अब इसी तरह से लिखते हैं ना इसको, right? We start differentiating. What is the first term? 3x cubed. The derivative will be what? 9x square. What is the second term? 5. Now I can treat this as a product of two terms because they are both variables. So I will use the product rule here. Now, when I differentiate with respect to x, that means I will have to treat y square as constant. So derivative of x is 1. So first term will be y square, right? But what about the second term? That means I'll have 5x with me, but now I have to write the derivative of y square. Now, the derivative of y square will be the derivative of y. And because my y was the dependent variable, so I will have to write dy by dx with it. ये याद है कि नहीं है? इसी तरह से करते थे.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Similarly, the other terms, they can be differentiated. ठीक है ना? So what I want to emphasize here is that whether I have an explicit function or I have an implicit function, I can differentiate. Not just differentiate, what I observe is that once we differentiate, right, I observe that it could be like, in this case, what will happen is that your dy by dx will also turn out to be some function of x and y. Here also, what have you observed? That your dy by dx is also a function of x. Okay, so a function, right? So that means when we are trying to find the derivatives, then is finding the first derivative enough? No, we have seen while sketching also, we have seen that though if the first derivative tells us the behavior of the function as well as it is increasing or decreasing, the second behavior tells us about the inflections of that curve, right? That was the geometric aspect of higher order derivatives. Now what we'll be learning is what are the algebraic or the analytic effects of higher order derivatives. Okay, now we have seen that first order derivative also turns out to be a function of x. That means I can differentiate it again. Now, when you differentiate it again, that means you are differentiating with respect to x, what? Dy by dx, right? Which is actually nothing but the second derivative of y with respect to x, which we also call as d2y by dx square. Okay. Now, if you differentiate this again with respect to x, what do you get? Again, a function, which can again be differentiated. So the question is that, is this process of differentiation possible as many times as we want? Number one. Number two, will every time am I going to get a derivative? Right? Or in other words, can I say that if I have a function, then it is going to be differentiable any number of times? And every time I'm going to get some derivative of the other or the other. Like, see, for example, talk सबसे आसान functions कौन से होते हैं? Polynomials, right? Let's take a function y equal to कौन सा लें? x cube, ठीक है? अब I can find it first dy by dx करूं या y1, मैंने y1 इधर लिख दिया, 1 here. This is a standard notation. If I say y1, that means the first derivative of y with respect to x. Okay, what will be y1?
3x square.
3x.
Okay, this is again a function of x. I can find y2, which is the second derivative. That means I have to differentiate 3x square. What will be that? 6x.
6x.
I can find y3. What will be that? 6.
6.
Can I find y4?
No.
Yes,
Zero.
ma'am. 0. Yes, ma'am. 0.
Yes, ma'am.
0.
y4 will be
0.
0.
निकाल तो सकता, कितना होगा?
0, ma'am.
0. What about y5?
0.
Not defined.
What about y6?
0.
ये किसने बोला भाई नॉट डिफाइंड? नॉट डिफाइंड किसने बोला? जल्दी बताओ.
Ma'am,
0 का डेरिवेटिव नहीं निकाल सकते?
ma'am, it's again 0.
Huh?
It's again and again 0.
हाँ, So what difference does it make? See, saying that derivative does not exist and saying that derivative exists but is zero are two different things.
Yes, ma'am.
Are you getting the point?
Yes,
Right?
ma'am.
So basically, y is zero and so on. No matter what order do I find, the derivative exists. It's not that the derivative does not exist, but the derivative happens to be zero. It's okay, fine. No problems with that. See, when we say the derivative exists, that means the function is differentiable. उसके बाद derivative क्या है, अभी हम उसकी बात नहीं कर रहे. Like polynomials के केस में क्या हो रहा है? देखो, तुम्हारा क्या था, x क्यूब था, कितने ऑर्डर तक नॉन जीरो डेरिवेटिव आया? थर्ड ऑर्डर तक. उसके बाद सारे ऑर्डर डेरिवेटिव्स क्या हो गए? जीरो. ठीक है. अगर मैं इन जनरल लिखूं y इक्वल टू, अच्छा सोचो, x टू द पावर 4 में क्या होगा?
4 डिग्री तक नॉन जीरो वैल्यू
y 4 तक नॉन जीरो आएगा. दैट मीन्स वील हैव अ नॉन जीरो डेरिवेटिव अप टू ऑर्डर 4. उसके बाद सारे जीरो हो जाएंगे, राइट? सो I have in general y equal to x to the power n, कुछ भी हो पॉलिनोमियल. इसका मतलब क्या हुआ? इसके हायर ऑर्डर डेरिवेटिव्स एग्जिस्ट करते हैं, बट एक स्टेज के बाद वो जीरो हो जाएंगे. यही होएगा ना, इससे ज्यादा तो कुछ नहीं होगा. अब अगर x टू दी पावर n है तो ज्यादा से ज्यादा nth ऑर्डर डेरिवेटिव मेरे पास नॉन जीरो आएगा ना.
यस मैम. यस मैम.
अब अगर मैं इसको चलो अभी हम जनरलाइज करने की, पहले समझ लो फिर जनरलाइज भी करेंगे, फॉर्मूले भी निकालेंगे nth ऑर्डर डेरिवेटिव्स के. ये तो हुई पॉलिनोमियल की बात, ठीक है. उसके बाद जो सबसे अच्छे फंक्शंस होते हैं, well behaved, the most well behaved functions, अभी ax नहीं, एक्सपोनेंशियल फंक्शन ex ही लेते हैं. ये तो बेचारा सीधा साधा फंक्शन है, कुछ नहीं कहता. चाहे इसको डिफरेंशिएट करो चाहे इंटीग्रेट करो, अब इसको अच्छा कह लो, अब इसको जिद्दी कह लो, ये कहता मैं नहीं बदलूंगा, यही कहता है ना. सो
यस
you have y1 ex, you have y2 ex, you have y3 ex and so on so forth. अब इस केस में क्या हो रहा है? इस केस में ये हो रहा है कि फंक्शन डिफरेंशिएबल है कितनी बारी, जितनी बारी आप सोच सकते हो, राइट? और उस पे द चेरी ऑन द केक इज दैट द डेरिवेटिव इज नॉट चेंजिंग. यू हैव द सेम फंक्शन एवरी टाइम. जो ex था वही y1 है, वही y2 है, वही y3 है, वही y4 है. इट इज नॉट चेंजिंग एट ऑल. ओके, सो दिस इज अ टिपिकल फंक्शन. डेरिवेटिव है. इससे पहले वाले में भी डेरिवेटिव थे, इनफाइनाइटली मेनी टाइम्स डिफरेंशिएबल था, बट उस केस में क्या हो रहा था? एक स्टेज के बाद सारे डेरिवेटिव जीरो हो रहे थे. इस स्टेज में क्या हो रहा है? वैनिश ही नहीं कर रहा डेरिवेटिव, जीरो नहीं हो रहा, बट सेम रह रहा है. ठीक है. इसी तरह से नेक्स्ट टाइप ऑफ फंक्शंस क्या हुए? ट्रिग्नोमेट्रिक, साइन एक्स. अब ये अलग ही तरह की इनकी अपने ही स्वैग है. कैसे? वो कहता है ठीक है चेंज होऊंगा बट थोड़ी देर के लिए. इन द सेंस, व्हाट इज y1?
cos x
minus sin x.
What is y3?
Minus cos.
What is y4?
Sin x.
वापस आ गए?
Yes,
हो गए
ma'am.
थे? ठीक है ना. So it's like they are periodic functions. Why? Because they repeat their behavior after a certain interval. So not just graphically do they repeat their behavior, even algebraically they repeat their behavior. Analytically also they repeat their behavior. So their derivatives keep on repeating. अब इसका मतलब क्या हुआ? ये प्रोसेस फिर से शुरू हो जाएगा जो हमने यहाँ पे किया. ये y4 के बाद फिर y5, y6, y7, फिर y8 वापस आ जाएगा. ठीक है ना? तो इसका मतलब क्या हुआ, फंक्शन तो ये भी डिफरेंशिएबल हुआ, कितनी बारी, जितनी बारी मैं चाहूं उतनी बारी, बट डेरिवेटिव्स कीप ऑन रिपीटिंग देमसेल्व्स। इस केस में डेरिवेटिव चेंज ही नहीं हुआ, वही का वही रहा। सेम विल बी द केस विद cos x, एक स्टेज के बाद रिपीट होना शुरू हो जाएगा, ठीक है? नाउ आई एम टॉकिंग ऑफ टिपिकल फंक्शंस बिकॉज हम इन्हीं का ही आगे डिटेल में स्टडी करेंगे। नेक्स्ट इज जब एक्सपोनेंशियल करा, लेट्स सी हाउ दिस काइंड ऑफ अ फंक्शन बिहेव्स, लॉगरिथमिक फंक्शंस, ठीक है? Logarithmic functions are interesting because you know they have a typical behavior because ये शुरू किसी तरह से होते हैं और एंड किसी और तरीके से करते हैं। In the sense, if y is log x, what is y1?
1 by
One
x.
What is y2?
Minus
minus
1
1 upon x square.
What is y3?
1 by x cube.
2 by
2 by
x.
x, 2 by x cube.
Y4 minus
Minus
6
6 upon x cube 4.
and so on. So that means again the function is differentiable as many times as I want. Okay, but for the derivatives to exist, I just want my x to be non-zero. ठीक है ना? तभी तो एग्जिस्ट करेंगे, अदरवाइज तो सारे डेरिवेटिव्स इनफाइनाइट होते जाएंगे, right? So these are certain typical class of functions, you know, which we'll be studying in details, you know, कि इसके डेरिवेटिव्स हम निकालते कैसे हैं या आगे कहाँ काम आते हैं। अब जैसे आगे काम कहाँ आते हैं मैं बताती हूँ। सबने थोड़ी सभी ने फिजिक्स, आई थिंक ऑल ऑफ यू आर साइंस स्टूडेंट्स हियर, तो सबने फिजिक्स पढ़ी है, ठीक है? हाउ डू वी डिफाइन स्पीड?
Distance upon time.
Distance upon time.
Change of distance with respect to time.
एक मिनट,
Distance by time.
Changing with respect to
ये फर्स्ट ईयर में आ गए हो, आगे भी काम आएंगी ये चीजें, ये ध्यान में रखना है हमेशा। जब कोई पूछ रहा है व्हाट डू यू मीन बाय दैट, यू आर सपोज टू डिफाइन इट। जो तुम दे रहे हो वो फॉर्मूला है।
The rate of change of distance.
हाँ जी, और अच्छा
The
अब
distance covered per unit time.
Distance per unit time.
The motion of any object
अरे
defines
अपनी
speed.
अपनी डेफिनेशन क्यों बनाते हो? क्रिस्प डेफिनेशन होनी चाहिए। और वेलोसिटी क्या होती है? चलो,
The change in displacement.
change of displacement with
the rate of change of displacement with
Displacement.
respect to time. ठीक है, चलो स्पीड को भूल जाते हैं because speed is a scalar quantity and velocity is a vector quantity. ठीक है, अब इसको if you remember कैसे डिनोट किया था? ds by dt
dt.
Yes, ma'am.
ऐसे डिनोट किया था ना। और s क्या था हमारा? डिस्प्लेसमेंट फंक्शन।
Displacement.
ठीक है, if s is the displacement, then rate of change of displacement with respect to time is the velocity. What is acceleration?
The rate of change of velocity with respect to time.
ठीक है, जिसको आपने बोला dv by dt, यही बोला था ना, which is actually nothing but d by dt of ds by dt,
Yes,
ठीक है,
ma'am.
which was actually nothing but d2s by dt square. यही किया है ना, ठीक है?
Yes, ma'am.
That means the second derivative of displacement with respect to time is acceleration. ठीक है?
Yes, ma'am.
अभी तक तो मैंने कुछ गलत नहीं बोला ना?
Yes, ma'am.
अब भाई जब सेकंड डेरिवेटिव फर्स्ट डेरिवेटिव का एक फिजिकल इंपॉर्टेंस है, सेकंड डेरिवेटिव का एक फिजिकल इंपॉर्टेंस है, तो क्या हम थर्ड डेरिवेटिव की बात कर सकते हैं? d3s by dt cube. कर सकते हैं? क्या होगा? सोचो। हिंट, थोड़ा सा इमेजिन करो कि तुम गाड़ी में जा रहे हो, ठीक है? अब ये क्या हो रहा है? d3s by dt क्यूब क्या हुआ? एक तरह से अगर मैं एक्सेलरेशन को a से डिनोट करूं तो isn't it dA by dt? यही होगा ना?
Yes, ma'am.
Yes, ma'am.
इसका मतलब क्या हुआ? दिस इज रेट ऑफ चेंज ऑफ एक्सेलरेशन,
Velocity.
रेट ऑफ चेंज ऑफ एक्सेलरेशन विद
Yes,
रिस्पेक्ट टू टाइम, ठीक है? इसका मतलब चेंज किस में करना है? एक्सेलरेशन में, ठीक है? अब एक्सेलरेशन का लिटरल मीनिंग ले लो, मतलब कि तुम कार में जा रहे हो, ठीक है, और बहुत स्पीड से चल रही है कार, ठीक है, एक्सेलरेशन बहुत ज्यादा है, ठीक है, एंड ऑल ऑफ अ सडन उसमें हम चेंज लाते हैं, मतलब ऑल ऑफ अ सडन ब्रेक लगाते हैं, तो क्या फील होता है?
Jerk.
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 Jerk, right? So the rate of change of acceleration with respect to time or d3s by dt cube is jerk. Simple. By ye, now this has become so common that it has come on t-shirts also.
Shan Singh Rajput.
Yes, ma'am.
तभी फेमस हुआ है ये. So, and you know, I saw a boy, ये तो अब इतना common हुआ है, almost 3 years back, I saw one boy wearing this t-shirt. And I was about to ask him, wow, you love maths. Don't be a d3s by dt cube. Okay? So it's a jerk. So now onwards, I know I'm going to get answers to this derivative. अभी तक नहीं आता था. So it has become common now. Okay. So now what I mean to say here is that we can find higher order derivatives physically, and every order derivative has its significance, whether it's physical or it's geometrical or analytical or anything, but everything has a significance here. So that is why higher order derivatives play an important role in calculus. So we need to study them in details, okay? And we need to study them further, we need to explore them further and then see how they behave, okay? Now, ये तो अब physics में हमको इसका दिख गया direct example, and definitely in equations of motions, yes, they play an important role. But of course, अभी तक आगे fourth order derivative का किसी ने अभी तक कोई नाम नहीं दिया है. The research is open. You can find something and then name it after you, okay? So it's like that. So what we do here, what we'll be doing here is we'll be studying these higher order derivatives in general, okay? And we'll be studying a few major things. Number one, we'll be in fact deriving the general formulae, you know, how to write the nth order derivative directly, okay? Like say, supposing I give you y is say sine 5x and I ask you to find y25, okay? So, I mean, if you keep on differentiating it again and again and again, 25, it's going to be too tedious a job. So if we are able to find certain formulae, you know, where we can find the nth order directly, nth order derivative, and then what do we have to do? We just have to substitute that n in that formula, and then we are done with that. Okay, so that is one thing that we'll be studying now. Second, because, okay, if I have a single function, it's fine. But what if I have a function like y is equal to x cube e to the power 10x? Okay, and I ask you to find y10. That means the 10th order derivative for that. Now, if you just look at this, x cube is a polynomial itself, जिसका अभी हमने पहले define कुछ study किया, बात करी. Then this is also an exponential function. We have discussed it just a few minutes back. Now, what do we have? We have a product of two. Okay. Now, as far as differentiation is concerned, we know that if I have a product of two functions, in the sense that if my y is uv, right, I can find the derivative. In the sense, product rule laga sakte hain isme. So what will be that? The first derivative, the derivative of first into v plus the first function into the derivative of the second function. Yahi hota na product rule. But what I observe is that the moment I write the first order derivative, the terms increase. So if I have to differentiate it again, that means instead of one term, I'll have two more terms. So instead of this, two more terms, and so on and so forth. So that means the way we have a product rule to find the first order derivative, can we have a product rule to find the nth order derivative directly? Instead of differentiating it again and again, we can have a formula to find the nth order derivative of a given function straight away. Okay, and this is the second thing that we'll be studying in this chapter now. And this answer was given by Leibniz. And the method to find this derivative is still called as the Leibniz rule, to find the nth order derivative when we have a product of two functions. Okay, so we'll be first learning the Leibniz rule, and then we'll be doing problems by applying the Leibniz rule. Okay, so these are the two things majorly that we'll be doing in this chapter. Okay, so to find the nth order derivatives, say supposing I have किससे शुरू करें? Polynomial से ही कर दें? If I have y as say x to the power n, चलो सबसे पहले इसी का ही nth order derivative का formula derive करते हैं. Okay, my y is x to the power n directly. What will चलो n ही रखते हैं, कोई बात नहीं. What will be the first order derivative?
nx to the power n minus
nx to the power n minus 1.
Nx to the power n minus 1. What will be the second order derivative?
Ma'am,
n
n
into
into
n minus
n minus 1 x to the power n minus 2.
What will be the third order derivative?
n into n minus 1 into n minus 2 x to the power n minus 3.
n minus 3.
ठीक है, और अब ये कब तक कंटिन्यूड रहेगा?
nth term.
nth
n तक. अब n पे क्या आएगा? n into n minus 1 into n minus 2 and so on so forth. कहाँ तक चलेगा?
n minus n. Sorry, n minus n plus n into
n minus n plus 1. So that is what? 1. यहाँ इसको यहाँ है, मैंने यहाँ रफ वर्क कर दिया. x4 से शुरू करते हैं तो ज्यादा अच्छा समझ में आएगा. ठीक है. What is y1? 4x cube. What is y2? 4 into 3 into x square. यही आ रहा है ना? n यहाँ पे n minus 1 था, यहाँ क्या आ गया? 4x cube. This is same as this.
फैक्टोरियल यूज करेंगे?
क्यों नहीं करेंगे? बिल्कुल करेंगे. 4 into 3 into 2 into x. And what will be y4? 4 into 3 into 2 into 1. यही आएगा ना? So your yn will be what? N into n minus 1 into n minus 2, so on till, of course, 2 into 3 into 2 into 1, something like that. That's how it is going to end up. And what is this term?
n factorial.
N factorial. Okay. So if you have y as x, if your function is x to the power n, that means the nth derivative is n factorial. And accordingly उसको हम use कर सकते हैं. आगे कैसे use करेंगे? I'll do more problems based on that. Similarly, if you have something like अब exponential पे भी आ सकते हैं हम. Say let's take y equal to e to the power ax लेते हैं, ठीक है? Not just x. उससे ज्यादा अच्छा रहेगा. Say y is equal to e to the power ax. So what is y1?
A to the power ax.
A into e to the power x.
Okay. What is y2?
A square e to the power ax.
E square e to the power ax. y3?
e के power ax.
अब जनरल फॉर्मूला लिख सकते हैं yn का.
A to the
Ma'am,
power
a to the power n.
e to the power ax.
Is this okay? This becomes the formula for nth derivative for e to the power ax. ठीक है? Then I wanted to do certain more. हाँ. अच्छा चलो इसको करते हैं. पहले एक सिंपल फंक्शन लें, फिर इसको कॉम्प्लिकेट करते हैं. या जनरल ले लेते हैं. चलो जनरल से ही शुरू कर लोगे. 1/ax plus b. Supposing this is the function and you have to find the nth order derivative for this. 1/ax plus b. डायरेक्ट इसको करोगे या पहले 1/x को करोगे फिर इसको करोगे? जैसे बोलो. दो ऑप्शंस हैं.
मैम पहले
ये
पहले 1/x.
ओके पहले 1/x को कर लो. चलो तो फिर ये होमवर्क हो जाएगा. ठीक है. If y is 1/x, what is y1?
-1 by x square.
What is y2?
-2
by x cube. 2 by x square.
Plus या minus?
Plus, ma'am.
What is y3?
-6
-3 by x to the power 4. -6 by
Minus 6 upon
x to the power 3. 4.
4. अच्छा एक चीज जो मैं देख रही हूँ. चलो एक दो और लिखो फिर जनरलाइज करेंगे. y4
24 by x to the power 5.
y5
-120 upon ax plus b.
x to the power 6.
6.
and so on so forth. ठीक है ना? यही आ रहा है. अब आई थिंक इतना बहुत है जनरलाइज करने के लिए. इन द सेंस वन थिंग दैट आई एम ऑब्जर्विंग इज कि जितने ऑड ऑर्डर डेरिवेटिव्स हैं वो सब नेगेटिव है, क्योंकि अब मेरे को फॉर्मूला लिखना है ना yn का.
यस मैम.
इसी को ही तो जनरलाइज करना है मुझे. ठीक है. जो हमने जो ये किया इन सबको जनरलाइज करेंगे अब हम. ठीक है ना? कैसे? पहले देखते हैं. y1 नेगेटिव था, y2 पॉजिटिव है, y3 फिर से नेगेटिव है, y4 पॉजिटिव है, y5 फिर से नेगेटिव है. इसका मतलब ऑल्टरनेटली प्लस माइनस आ रहे हैं. ठीक है. तो डेफिनेटली मैं इधर एक साथ माइनस या प्लस तो नहीं लिख सकती. डेफिनेटली -1 की टर्म आ रही है. ठीक है. बट और डेरिवेटिव्स तो माइनस हैं और इवन डेरिवेटिव्स
नहीं है।
प्लस है, ठीक है ना। तो इसका मतलब n से रिलेटेड हो गया ना, मतलब अगर n 1 है तो माइनस है, n 2 है तो प्लस है। क्योंकि देखो जब हम जनरलाइज करते हैं ना तो हमें यहाँ भी हर चीजें n की टर्म्स में लिखनी पड़ेंगी। जैसे तुमने ऊपर लिखा yn को हमने क्या कर दिया, n फैक्टोरियल, ठीक है ना। अब इसमें क्या हो जाएगा कि अगर यहाँ पे मैं nth डेरिवेटिव लिख रही हूँ और अगर यही फॉर्मूला यूज करके मुझे y3 निकालना है सपोजिंग, इसी को यूज करके, तो ये माइनस होना चाहिए। इसका मतलब अगर यहाँ पे ऑड है तो यहाँ पे भी ऑड होना चाहिए, और यहाँ पे इवन है तो यहाँ पे भी इवन होना, यहाँ पे इवन होना चाहिए। तो अगर मैं इसको क्या लिखें फिर हम, -1 to the power
-1 to the power n.
n, ठीक है ना। तो जब n 1 होगा तो यहाँ भी 1 होगा, n 2 होगा तो यहाँ भी 2 होगा, ठीक है। इज दिस ओके?
Yes, ma'am.
Yes.
ठीक है। अब उसके बाद की टर्म
Yes, ma'am.
देखते हैं हम बाद में कैसे। अब बाद में जो हमने देखा तो
1 by x to the power n plus 1.
समथिंग अपॉन समथिंग है, ठीक है ना। अब हम ये ऑब्जर्व कर रहे हैं कि x जो है वो सिर्फ डिनोमिनेटर में ही रह रहा है, न्यूमरेटर में तो जा नहीं रहा, ठीक है। तो इसका मतलब यहाँ पे तो x है, राइट। बट फर्स्ट डेरिवेटिव था तो x स्क्वायर था, सेकंड डेरिवेटिव था तो x क्यूब था, थर्ड था तो 4 था। तो यहाँ पे क्या होना चाहिए, x टू दी पावर
n plus 1.
n plus 1.
n plus 1। यहाँ तक तो ठीक है। नाउ लेट अस सी हाउ द कांस्टेंट टर्म्स बिहेव। फॉर द फर्स्ट आई हैव 1,
And ma'am.
for the second I have 2, ठीक है, that is okay, but for the third I have 6. Okay, now this 6 I can write as 2 into 3, लिख सकते हैं।
Factorial again.
n factorial.
n factorial, ma'am.
4 I have 24, which is, so it should be n factorial. Okay, so this becomes the nth derivative formula for y equal to 1 by x. So if somebody says for y equal to 1 by x, find y12. So what you have to do, simply replace n by 12 here and you have the answer. Is this okay?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So now as a homework, try to generalize the formula for 1 upon ax plus b. अब इसमें एक a की टर्म और एक्स्ट्रा आएगी साथ में, बाकी कुछ तंग नहीं करेगा, ठीक है। इट्स जस्ट कि x की जगह मेरे पास ax प्लस b है। ओके, so जिस तरह से हमने 1 by x को जनरलाइज करा है, ऐसे ही 1 upon ax प्लस b को भी आप जनरलाइज करो, ठीक है। So I'm
Yes, ma'am.
finishing off my class now because it's time and you have the next class.